Okay, so this week we are going to be talking about solutions, concentration, and a few other topics before we start getting into acids and bases that have to do with colligative properties. We dealt with colligative properties a little bit when I talked about Raoult's law. I decided to postpone it until now because most of the calculations are not dealing with vapor pressure or anything. They're dealing with other physical changes like boiling point and freezing point. So today we're going to be doing concentration, and that refers to concentration of any type of solution that you make. So if you remember, just to recap, a solution is composed of a solute and a solvent. So if you remember, a solute gets dissolved, and then a solvent does the dissolving. Alright. So something you need to know. So expressing, and this is super, super important for chemistry. Okay, so expressing solution concentration comes in a few different forms. It just depends on the concentration of the solute in the solvent, what type of calculation you're doing, depending on amounts, and there's a few scenarios where you would use each one. So I'm going to go over how to calculate concentration, and then we're going to go into what a dilution is, and then we're going to do some practice. But anyways, let me start with the one you are going to be hearing a lot of, molarity. Let me write that better. So molarity is expressed with a capital M, and molarity equals moles of the solution, or of the solute, divided by the liters of the solution. So it's also used as a conversion factor. You will be using this a lot. Alright. Our second would be molality. So molality is used more when you're doing very large quantities, but it's expressed with a lowercase m. And it is m equals kilograms of solute. Moles of solute. I don't know what I was thinking. Moles of solute divided by kilograms of solvent. Let me just remove that. It's bothering me. So this is used more for like industry and stuff like that. It's not really used too often, but there are specific cases when you'd use it. And then 3 would be parts by mass, which if you've ever heard like, oh, it's got this many particles in parts per million, that's when you would use something like this. But that's calculated a little differently. Parts by mass. So that would be mass of the solute divided by mass of the solution times 10 to the power of x. So over here, I'm going to draw a little table for you guys, and feel free to copy this. So you have x And then you have 9, 6, and 2. Those are the most common. So you have parts per billion, parts per million, and you have let me write that, mass percentage. And then this would be units. I'll give you a second to copy that. Let's see what I'm doing on time. All right, perfect. So I'm going to go over an example real quick. And then we are going to go on to dilution. So you feel free to copy this. A solution is prepared by dissolving 50.4 grams of sucrose. Sucrose is table sugar. So the molar mass is 342.2 grams per mole. And then you're dissolving this sucrose in 0.332 kilograms of water. So H2O. So the final volume of the solution is 355 milliliters. Calculate the solution in each of the following units. So we're going to have A, molarity, B, molality, and then C, let's just do percent mass. Okay, so I don't have enough room to do this, so pause the video and copy this if you're not done copying it, and then we're going to continue on another page. So, wow, let's write everything down. So our solvent is most definitely water. And then, yeah, this is easy. We have everything we need to do all three of these. So if you remember, molarity, well, I can't write today. Molarity equals, or I'm going to just do molarity is M equals N over L, or N over V, N over volume. So in this case, we're given a volume of the final solution, but it's got to be in liters. So let's make a note of that. I'm going to do that on the previous page. Sorry about that. Anyways, and I'll make another note of it down here. Okay, so you have 355 milliliters. You have to convert that to liters. Over 1,000 milliliters. So that's canceled, and then essentially you're moving that over. So you have 0.355 liters. And then now you use the grams of sucrose and the molar mass to calculate how many moles you have. So N, and then we'll put V equals. N equals 50.4 0.4 grams times 1 mole over 342.2 grams. And then that cancels. And then you're left with, I don't have a calculator. Let me pull that up. You have 50.4 divided by 342.2, and that would be 0.147. Okay, so you have 0.147 mole. You have the liters. Let's find out what the molarity is. The molarity is 0.147 moles divided by 0.355 liters. So, divided by... And their answer is going to be roughly 0.41. 0.41 molar. So, that's how you would solve this one. I didn't say to specifically what significant figures. If you're doing it to significant figures to the proper amount, you'd have 3 and it would be 0.415. But I'm not too concerned about that. I'm mainly concerned with, can you get the concentration right? Now, or do the math right. Now, we have to do, for molality, remember it's moles of solute over kilograms of solvent. So molality is lowercase m equals n over kilograms. So in this case, the problem gave you this. You have 0.332 kilograms, and then you have your moles. Excuse me. So you have 0.1147 moles divided by 0.332 kilograms. And then this is equal to, let's do this in the calculator. We have 0.47 divided by 0.332. Oh wow, I don't know what is going on there. Alright, something... Hang on a second, my calculator's glitching out. Divide it. Alright, I'm gonna do it by calculator by me. Alright, the answer is gonna be about 0.445 molality. I'm gonna try and fix this real quick because it's really driving me nuts. I don't know what is going on, but okay, hopefully that fixes it. If not, we're just gonna use the calculator by me. But let me see if I can pull it up and fix it. So we had 0.147 divided by 0.332. I don't know what was going on before. But as you can see, it's about 0.44. Well, I didn't use the full rounded number. I did on my calculator before, so I'll show you. If you do 50.4 divided by 342.2, and then you use this and divide it by 0.332, you'll get about 0.444 or 444. We'll go with that. Either way, close enough. I'm not too picky. So that's how you would do molality. And then C would be your mass percentage. So your mass percentage is simply how much, it's just, you just divide the mass. It's really simple. So you had 0.332, and it doesn't need to be in grams, but you want everything in the same, otherwise you're not going to get the right answer. It's got to be in the same category. So you have kilograms of solvent, and you have grams of solute. You could convert either one, it'll give you the same answer. But I'm going to just do it to grams, so over 1 kilogram. And this will be 332 grams. And then it's very simple. You do 50.4 grams divided by 332 plus 50.4. Because if you remember, it's mass solute divided by mass solution. I might have wrote something else up there. I don't remember. I might have wrote solvent, but no, I didn't. Alright, so, and then this would be times 100% for mass percentage. You can't forget that part because otherwise you'll get the wrong answer. But let's do this in the calculator. So you have 50.4 divided by 332 plus 50.4 and then times 100. So your answer is going to be about 13.18%. So that's percentage per mass, or mass percentage. So that's pretty much it. Like, the determining the concentrations of a solution are super easy. So if you need to copy that stuff, just pause it. So now we're going over dilutions. So dilutions. So when you dilute something, that means you're making it a weaker concentration. So like, I don't know about you, but I know when I was younger, and this doesn't work that well, but you run out of soap. First thing everybody does is they just put water in the soap bottle, and it's like, it doesn't last. It seriously dilutes it, and it's not a good idea. But anyways, that's an example of diluting it that I think everybody, or most everybody, can see. Or when you add, like if somebody in the house is cleaning or you're mopping the floor, like I know I use vinegar, or sometimes I'll use bleach. And even though it's already diluted, you can dilute it even more by adding like this many parts water, this many parts, bleach or vinegar. It's the same thing. That's essentially what dilution is, and there's a way to calculate it. So we're going to be going over that. So dilution. I'm going to give you the definition first. It's a new solution with a lower concentration. Okay, so you can use an inequality to explain this relationship. So I'm going to do little brackets over here. So you have C1 and C2, and you have V1, V2. So if the concentration from C1 goes up to C2, that means the volume is going to go down. That's essentially the whole idea. So they're inversely proportional in a way. You have C1 V1 equals C2 V2. If you remember Boyle's law from the gas laws, this looks very familiar, doesn't it? So this equation will help solve the volume / concentrations of diluted solutions when you just have certain information to go on. So I'm going to give you a quick example. Let me pull my book over here so I can fix this. So if you dilute 25.0 milliliters of 1.5 molar hydrochloric acid to a volume equal to 500 milliliters, what is the molar concentration of the diluted solution? So I want you to take a second and think about this up here and how to solve it while I finish writing this, and then I'm going to go into it. So here we go. How would you set this up? Simple. Use the formula I gave you. That's why I gave it to you. So you have C1V1 equals C2V2. So not all of these are going to be this easy, but you don't have to convert between liters and milliliters. Like, you have the same volume, so that's fine. The concentration will be the same. It'll be molar. So usually it's good practice just to convert to liters, but in this case it's literally going to make no difference because you're in the same units. So as long as you're in the same units, you are fine. So that means we have 1.5 molar, that's C1, times 25.0 milliliters. And then that's equal to C2, which we don't know what it is, times 500 milliliters. So to solve this, you simply divide out 500 milliliters from both sides since it's an equation, and then you're going to be canceling out your milliliters. So that means your answer would be 1.50 molar times 25 divided by 500. So let's plug that in the calculator and see what it gives us. Times 25 divided by 500. So your answer is going to be 0.075 molar. So note, this is the last thing and then we're done with this unit, or this video. Note, for concentration and volume, and this is repeating what I said, as long as the units are the same, this equation will work. If you have to convert between milliliters and liters, it's because they're given to you in two different forms. So this equation will work. And that is where we're going to end it today for this, and then now we're going to be jumping into colligative properties. I'm going to probably do another video doing some problems with this. I haven't decided yet. But anyways, that's it.